Hi all, welcome to i-tutor Academy. In today's session, we will start with Unit 7, subsection 7, and we already discussed in Unit 7 till 7.6. So please refer last videos, and it's functional forms of production function. Okay, so this is about this subsection. So the production function can be estimated by regression techniques, and that we discussed in MMPC 005. So you can refer that also in our from our YouTube channel is there MMPC 005. Okay, so for this, one of the first task is to select the functional form, that is the specific relationship among the relevant economic variables. So we know the general form of production function is this is Q is equal to F of K and L. Here Q is output, K is capital, and L is labor. And although a variety of functional forms have been used to describe production relationship, only the Cobb-Douglas production function is discussed here. So general form of Cobb-Douglas function is like this, and a, alpha, beta are the constant that when estimated describe the quantitative relationship between the input, that is K and L. K is capital and L is labor, and this is Q is output. Okay, so this is all equation based. You can refer from your IGNOU study material MMPC 010 Unit 7 subsection 7. Okay, and having numerical estimates for the constant of the production function provides significant information about the production system under the study, and the marginal products for each input and return to scale can all be determinant from the estimated function. And the Cobb-Douglas function does not lend itself directly to estimate by the regression method because it is a non-linear relationship, and technically an equation must be a linear function of the parameter in order to use the ordinary least squares regression method of estimation. However, a linear equation can be derived by taking the logarithm of each term, and that is like this. And the function can be estimated directly by the least squares regression technique and the estimated parameter used to determine all the important production relationship. Then the anti-logarithm of both sides can be taken, which transforms the estimated function back to its conventional multiplicative form, and we will not be studying here the details of computing production function since there are a number of computer program available for this purpose. And the next is type of statistical analysis. Once a type of statistical analysis to be used in its estimation, generally there are three type of statistical analysis used for estimation of a production function, that is time series analysis, cross section analysis, and engineering analysis. Time series analysis, the amount of various input used in various periods in the past and the amount of output produced in each period is called time series data. Example, we may obtain data concerning the amount of labor, the amount of capital, and the amount of various raw material used in the steel industry during each year from 1970 to 2000. On the basis of such a data and information concerning the annual output of steel during 1970 to 2000, we may estimate the relationship between the amount of the input and the resulting output using regression techniques. Analysis of time series data is appropriate for a single frame that has not undergone significant changes in technology during the time span analysis. That is, we cannot use time series data for estimating the production function of a frame that has gone through significant technological changes. There are even more problems associated with the estimation a production function for an industry using time series data. For example, even if all frame have operated over the same time span, changes in capacity, input, and output may have proceeded at a different pace for each frame. This cross-section data may be more appropriate. And next is cross-section analysis. The amount of input and inputs used and output produced in various frame or sectors of the industry at a given time is called cross-section data. Example is here, so please go through your study material. Next is engineering analysis. In this analysis, we use technical information supplied by the engineer or the agricultural scientist. This analysis is undertaken when the above two types do not suffice. The data is in this analysis is collected by experiment or from experience with day-to-day working of the technical process. There are advantages to be gained from approaching the measurement of the production function from the angle, because the range of applicability of the data is known, and unlike time series and cross section studies, we are not restricted to the narrow range of actual observation. Next is limitations of different type of statistical analysis. Each of the method discussed above has certain limitations. So one is both time series and cross section analysis are restricted to a relatively narrow range of observed value. Extrapolation of the production function outside that range may be seriously misleading. An example is here. Please uh, go through your study material. Next is another limitation of time series analysis is the assumption that all observed values of the variable pertain to one and the same production function. In other words, a constant technology is assumed. In reality, most firms or industries, however, find better, faster, and or cheaper ways of producing their output. As their technology changes, they are actually creating new production function. One way of coping with such a technological change is to make it one of the independent variable. And third one is theoretically the production function includes only efficient combination of input. And if measurement were to conform to this concept, and any year in which the production was less than nominal would have to be excluded from the data. So it is very difficult to find a time series data which satisfy technical efficiency criteria as a normal case. And engineering data may overcome the limitations of time series data, but mostly they concentrate on manufacturing activities. Engineering data do not tell us anything about the firm's marketing or financial activities, even though these activities may directly affect production. In addition, there are both conceptual and statistical problem in measuring data on input and output. And it may be possible to measure output directly in physical units such as tons of coal, steel, etc. In case more than one product is being produced, one may compute the weighted average of output, the weights being given by the cost of manufacturing these products. And in highly diversified manufacturing unit, there may be no alternative but to use a series of output values corrected for each in the price of the products. One has also to choose between gross value and net value. It seems better to use net value added concept and instead of output concept in estimating production function, particularly where raw material intensity is high. And the data on labor is mostly available in the form of number of workers employed or hours of labor employed. The number of workers data should not be used because it may not reflect underemployment of labor, and they may be occupied but not productively employed. Even if we use man hours data, it should be adjusted for efficiency factor. And it is also not advisable that labor should be measured in monetary terms as given by expenditure on wages, bonus, etc. And the data on capital input has always posed serious problems. Net investment, a change in the value of capital stock is considered most appropriate, and nevertheless there are problem of measuring depreciation in fixed capital, changes in quality of fixed capital, changes in inventory valuation, and changes in composition and productivity of working capital, etc. Finally, when one attempt and the econometric estimate of the production function, one has to overcome the standard problem of multicollinearity among input and autocorrelation, homoscedasticity, etc. And next is managerial uses of production function. There are several managerial uses of the production function. It can be used to compute the least cost combination of input for a given output, or to choose the input combination that yield the maximum level of output with a given level of cost. And there are several feasible combination of input factor, and it is highly useful for decision makers to find out the most appropriate among them. The production function is useful in deciding on the additional value of employing a variable input in the production process, so long as the marginal revenue productivity of a variable factor exceeds its price. It may be worthwhile to increase its use. And the additional use of an input factor should be stopped when its marginal revenue productivity just equals its price. And production function also aid long run decision making. If return to scale are increasing, it will be worthwhile to increase production through a proportionate increase in all factors of production, provided there is enough demand for the product. On the other hand, if return to scale are decreasing, it may not be worthwhile to increase the production through a proportionate increase in all factors of production, even if there is enough demand for product. However, it may in the discretion of the producers to increase or decrease production in the presence of constant returns to scale and if there is enough demand for the product. So activity 2 here under this section, please try to do it. And summary of this chapter is here. Okay, so this is all about production function. Specifies the maximum output that can be produced with a given set of input in order to achieve maximum profit. The production manager has to use optimum input output combination for a given cost. So in this unit we have shown how a production manager minimize the cost for the given output in order to maximize the profit. Also we have shown how to maximize the output at a given level of cost. The law of diminishing marginal return states that as equal increment of variable input are added to fixed input, a point will eventually be reached where corresponding increments to output begin to decline. And we have also seen the relations between the marginal product, average product, and total product. There are three stages of the production. Stage 1 characterized by MP equal to 0 and MP is equal to AP, and stage 2 is characterized MP is greater than 0 and MP is less than AP, and stage 3 is MB is less than 0 and economically meaningful range is stage 2, and the production manager maximize the profit at the point where the value of marginal product equal the price of the output. So like that, an isocant consists of all combination of two input will be the yield the maximum output. Okay, so we all discussed this, although there are many different forms of production function. We have discussed here only Cobb-Douglas production function. Okay, so this is the summary of this unit, and here is self-assessment questions. Total 7 questions. Please try to do it. It will help you for your term and examination. Okay. In between any doubts, you can contact us anytime, and like your assignment, it's also important. Okay. And in between any doubts, you can contact us anytime. And for more MBA series, you just do like, share, and subscribe our channel. Thank you so much.
i-tutor Academy presents IGNOUMBA Complete Syllabus Coverage Classes for individual students, semester-wise subject with online flexible timing. For more details, contact on +91 623 827 1885